Hello and welcome to Quick Maths with Mr. Jonsen. In this video, I will work out the Cambridge IGCSE Mathematics Paper 4 for the year 2024, and it is the second variant. In my last video, I finished doing up to question number 9. So today I'm planning to finish question number 10 and 11. So let us start. A is the point 6, 2 and B is the point 3, minus 4. Part 1. Find the coordinates of the midpoint of AB. So the midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. Okay. So let's say this is x1 and y1, this is x2 and y2. So let's substitute those values here. 6 plus 3 divided by 2, comma y1 is 2 plus minus 4 is minus 4 divided by 2. So let me write over here, that's going to be 9 over 2, comma minus 2 over 2. So the coordinates of the midpoint of AB is going to be 4.5 and minus 1. Let's go to number 2. Calculate the length of AB. Again, the formula for the length, usually we write that as distance between 2 points A and B is going to be the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So what are we doing over here actually is we are just finding the difference in y coordinates and squaring it, and then the difference in x coordinate and squaring the value, and then finally taking the square root of that. Okay, so here we have, again going back, y2 is minus 4, so square root of minus 4, this is minus 4, and then y1 is minus 2 all squared plus x2 is 3 minus x1 is 6 all squared. So let me write down over here. That will give me the square root of minus 2 minus 4 is minus 6, and when you square negative 6 you get 36, plus similarly 3 minus 6 is minus 3, minus 3 squared is 9, and then finally square root of 45. Alright, so square root of 45 is equal to 6.708. So that is equal to 6.708. So let me round this to 3 significant figures, that is 6.71. Alright, let's go to part B. The equation of line L is 4x plus 3y minus 12 equal to 0. Number 1, find the gradient of L. The general form of the equation is y equal to mx plus c, and here in this case we need to rearrange this whole thing to make in this form. So subtract 4x and add 12 to both sides to balance the equation. So we have 3y equal to minus 4x plus 12. So y equal to minus 4 divided by 3x plus 12 divided by 3. This is the gradient. Okay, the coefficient of x, which is m, is the gradient. So in this case negative 4 over 3 is the gradient. And in part B it says find the coordinates of the point where L crosses the y-axis. Take this equation, y equal to negative 4 over 3 x, and then plus 12 divided by 3 is 4. Now going back to this format, y equal to mx plus c, this c over here is the y-intercept where it crosses the line L. Okay, let me just draw one rough sketch over here. This is x and here we have y. Since the gradient is negative, the line slopes downwards. This is the point where the line crosses the y-axis, and the value of that over there is 4. So when y is 4, what is the value of x? X is 0, so that is 0, 4. Alright. Number 3, line P is perpendicular to L and passes through 6, 5. Find the equation of P in the form y equal to mx plus c. Alright, so so first of all, gradient of line L is negative 4 over 3, and we need to find the perpendicular gradient. So perpendicular gradient is the negative reciprocal of the original gradient. Okay, so that becomes 3 over 4. Since it is negative, it turns into positive, and 4 over 3, you just flip it upside down. And now we know the gradient of the perpendicular line P. Let me write part of my equation as y equal to 3/4 x plus c. Now we need to find the y-intercept. Going back to this point, this is x and this is y. Let us substitute the values of x and y right over here so that we can find c. So y is 5, so 5 equal to 3/4 times x, which is 6. Here we have 6, plus c. So 5 is equal to 3/4 of x is 4.5. Okay, plus c. Subtract 4.5 from both sides, you will get c. So c is equal to 5 minus 4.5, c equal to 0.5. Or you can write that as half. Now our equation is already halfway through over here, and we have found the y-intercept, which is half. The equation is 3/4 x plus half. Alright guys, so let us go down to question number 11. 11a. The point -1, 6 lies on a curve. This curve has the derived function dy over dx equal to -4x cubed minus 9x squared plus 5. Show that -1, 6 is a stationary point of the curve. Now, a stationary point is where the derivative of a function is equal to 0. So they have already derived this function over here. Okay, so let me just write dy over dx for any stationary point is equal to 0. So that is right over here. So we can write that as -4x cubed minus 9x squared plus 5 equal to 0. Okay, and substitute the value of x into this expression. That's -1. So -4 times -1 cubed minus 9 times -1 squared plus 5 should give us 0. Let us tidy up this little bit. -4 times -1 cubed is -1, and then -9 times -1 squared is 1. Okay, plus 5. So let's do this first. That will give you +4. Negative times negative is positive. Negative times positive is negative, and plus 5. equal to 0, equal to 0. Now 4 plus 5 is 9, minus 9 equal to 0. So that's how we show that minus 1, 6 is a stationary point of the curve. Moving down to question 11, part B. A different curve has equation y equal to 2x cubed minus 6x plus 8. Number 1, calculate the gradient of the tangent to this curve at the point minus 2, 2. Alright, so the gradient of the tangent of this curve. So let's derive this, okay? dy over dx equal to, now if you look at this power, which is 3, you need to multiply with the coefficient of x. So 2 times 3 is 6x, and the power comes down by 1, so 3 becomes 2. Alright, 6x squared, and then now the power of x is 1 over there, so multiplying 6 by 1 will give you minus 6, and then when you reduce the power from 1 to 0, then that is going to disappear because x to the power of 0 equal to 1. And when we multiply with minus 6, that stays minus 6, and the constant term will just go away. So that's the derived function of the curve. Now we need to calculate the gradient of the tangent at the point minus 2, 2. So let us substitute this value of x into our derived function, okay? So let's say this as 6 times negative 2 all squared minus 6. That is 6 times negative 2 squared is 4 minus 6, and that is 24 minus 6. 24 minus 6 is 18, and that is the gradient of the tangent. And in part 2, find the coordinates of the stationary points of this curve. Again, going back to the stationary points, as I told you, where the derivative of a function is equal to 0. Here I have written that, okay? So let us do the same thing. We have derived the function over here. Let us set this equal to 0. So that is 6x squared minus 6 equal to 0. Alright, now we need to solve this equation. Okay, try to get rid of the coefficient of x squared. We can do that if we divide by 6, but now we need to divide every term by 6. So this will go away. We have x squared minus 6 divided by 6 is minus 1. 0 divided by any number is 0. So here we have x squared minus 1 equal to 0. Then x squared will be 1, because if you take this to the other side, and then x is equal to the square root of 1, which is positive or negative. Alright, so square root of 1 is 1, so it can be 1 or it can be minus 1. You can also use, if you don't want to do that, we have another method, that is when we have x squared minus 1 equal to 0. If you remember one of the algebraic identities, a square minus b square equal to a plus b times a minus b. So 1 is a square number, so we can write that as 1 square. So this is going to be x plus 1 times x minus 1 equal to 0. So either x plus 1 equal to 0 or x minus 1 equal to 0. So x equal to minus 1 or x equal to 1. Alright, thank you very much.